Hello students. Today we will discuss a topic, resistance. What is resistance? Resistance can be defined as opposition to the flow of current. Opposition to the flow of current. I will explain you with the help of example. That we have a very small circuit. Here voltage source is 20 volt and resistance is 10 ohm. When we close this circuit, a current will flow through this circuit I, whose value can be find out with the help of Ohm's law. V is equal to IR. So voltage 20 volt, I we have to find, resistance is 10 ohm. So I will be equal to, it is 2 ampere. Let resistance is increased by to 20 ohm. Then when we close this switch, then current I will be 20 divided by 20, it is 1 ampere. So as we have increased the value of resistance, the value of current decreases. So resistance opposes the current. Now we have resistance in series and resistance in parallel. We will check, I will tell you the formula when number of resistances are connected in series. Let we have three or four resistance which are connected in series. 1 ohm, 2 ohm, 3 ohm, R1, R2, R3. And a voltage source of 20 volt is connected to it. When we close this switch, a current I will flow through the series circuit, and the voltage drop across this R1 is V1, voltage drop across this R2 is V2, and voltage drop across R3 is V3. Now, when we close this switch, this current will flow through this circuit, and this total voltage is equal to this voltage, this voltage, this voltage, sum of three voltages across R1, R2, R3 and R3. Now what is V? V is equal to IR with the help of Ohm's law. Now current is same. In series circuit, current will be the same throughout the circuit. In each resistance, the value of current will be same. Now what is V1? It is IR1, V2, IR2, V3, IR3. So take I common, we have R1 plus R2 plus R3, and I will cut, and R is equal to R1 plus R2 plus R3. So when resistances are connected in series, then their total value will be equal to sum of the individual resistances. That will be 1 plus 2 plus 3, 6 ohm. So series total value of the resistance in series will increase, and it is very much greater than the individual resistance. 6 is greater than 1 ohm, greater than 2 ohm, and greater than 3 ohm. Now we will check when resistances are connected in parallel. Let these same three resistances, they are connected in parallel across a voltage source V. 1 ohm, 2 ohm, R2, 3 ohm, R3. Now in parallel circuit, when we close this switch, a current I will flow through this circuit. Voltage is parallel, so voltage across each resistance is same in parallel circuit. voltage across each resistance will be same in parallel circuit. This voltage, this voltage, this voltage, this voltage is same. And in series circuit, we have current flowing through. In series circuit, current flowing through. Voltage across in parallel circuit. Current flowing through each resistance is same. So you have to remember this. Now this I is equal to, but different current flow through the three resistances, and I will be divided into I1, I2 and I3. So I will be equal to I1 plus I2 plus I3, and I is equal to I1. What is I1? V divided by R3, V divided by R1, V divided by R2, V divided by R3. And what is I? I is equal to V over R. R is the total resistance of the circuit. So V will be taken as common, 1 over R2 plus 1 over R3. So V will be cut, and 1 over R is equal to 1 over R1, 2 plus 1 over R3. And when we will calculate this, 1 over 1 plus 1 over 2 plus 1 over 3, it will be, LCM will be 6 plus 2, 3 plus 2. It is 11 by 6. So 1 over R is equal to 11 by 6, which implies that R is equal to 6 by 11. 6 by 11. It is something 0.5. 0.4. So in parallel, total value of the resistance will become very less as compared to the individual resistance, because total value of resistance is 0.54 ohm and individual resistance is 1 ohm, 2 ohm and 3 ohm. So this resistance is used in many fields, in every field of the electronics. So I will tell you later on. So this is something about resistance. Okay, thanks students. We will discuss it in detail, this topic, in the next lecture. Okay, thanks.